Resistors. Those funny little things with the lines on them? You've heard they can save your circuits, but is it really true? Let's find out. This is what happens when you connect an LED directly to a 9-volt battery. Well, unfortunately, it looks like the end of the line for our poor test subject here. Now, thankfully, LEDs aren't too hard to come by these days, but if you're working with important or expensive circuits, you probably want to make sure that they don't blow up. And the best way to do that is to limit the amount of power that goes into them. And the perfect component for that is the resistor. Resistors are components that restrict the flow of electric current through a circuit. Found in basically all electronic devices, they follow what's known as Ohm's law, which relates the voltage across the resistor to the current that can flow through it. So now that you know how to calculate the resistance you need in a circuit, the next thing to do is to figure out which resistor to use. Now, if you buy a packaged resistor, it'll tell you right on it, this is 220 ohms. Absolutely no problem. But what happens if you're like me and you've got a pile of resistors and you want to see if you've got approximately the right value to use? Well, it turns out this is easy to do because each resistor has on it 4 colored bands which tell you the amount of resistance that it has. For example, let's look at this resistor. You can see that it has 4 bands on it: yellow, purple, orange, and gold. The color of the first 2 bands correspond to the first 2 digits of the resistor's value, and the color of the third indicates the number of zeros that come after those digits. The final band indicates the tolerance of the resistor, which tells us the maximum difference between the resistance written on the resistor and its actual value. Here, yellow corresponds to 4, purple corresponds to 7, and orange corresponds to 3, meaning that there's a 47 with 3 zeros after it. This brings the total resistance of the device to 47,000 ohms, or 47 kiloohms for short. The final thing to consider when choosing a resistor is its power handling capability. Choose one with too low of a current rating, and it may meet the same fate as that LED. Fortunately, this is easy to figure out because it basically correlates to the size of the resistor. The larger the resistor, the more current it can handle, and the smaller, the less. For example, here are 3 resistors that I happen to have in my bin. The first one is the smallest, so it'll carry 1/8 of a watt. The second one, 1/4, and the third, and largest, 1/2. Though it is often overlooked, calculating the power requirement for a resistor is actually pretty easy to do. Just take the current that you expect to go through the device and multiply it by the voltage drop across it, and that gives you the amount of power. Choose a resistor that has a larger power capability than that, and you should have no problems. So let's try that LED circuit over again, only this time, let's use a resistor and try not to blow it up. To do this, we'll need a breadboard, a resistor, 220 ohms, an LED, this one is orange, and we'll need a 9-volt battery and a clip. Okay? Let's start with the resistor here. To make the resistor easier to stick into the breadboard, use a needle-nose pliers to bend each leg of the resistor at a 90-degree angle. This helps keep the circuit neat and also adds strength to the wires by ensuring that they stay straight. Press the resistor down firmly into the breadboard, and then connect the long end of the diode to the resistor. Finally, connect the 9-volt battery leads. Positive goes to the resistor side, and negative goes to the diode side. Plug in the battery, and we have another success story. 1 LED, no explosions.